try it this way. We got my annotation device and then the computer. Then we're going to talk about Introduction to Functions 11. This is Unit 4. In case you're just joining us, we were in Unit 3, which looks like it was 1 week, but it's actually 2, I think. And since it's now December 5th, I've made the decision that we're going to table systems of equations, come back to it in unit, wait for it, 7, which will occur sometime in the spring. Okay. So right now we're going to jump on into functions so that we can do some geometry in the winter. And good. All right, so what in the world are functions? So I will tell you, I will answer that. Okay. And just one more time, these videos here are important. Okay. So this is your note. I am not, babbling on and on in front of you. Okay. So evaluate notes or evaluate functions in your notes and write this one down with the directions and let's talk about it. Let me see if this, okay. All right. So now, let's see. Ta-da, we have that function there. And I also, so when we talk about functions, we have inputs and outputs. Okay, the inputs are x. This is also the domain. So there's related words here. The domain is the set of all inputs. The range is the set of all outputs. And you guessed it, the outputs are our y values. And in Math 8, we usually write functions like this. F equals 2x plus 3. And then you're like, okay, f, fine. It's a different variable. But actually, in Algebra 1, we write it like this. And the reason we don't write that with the Math 8 students is because it's confusing. F times x? No, that's not what that says. This is f of x, called function notation. It's a brand new way to write something, and it's not multiplication. This means that our input, see, our input x is right there. And so what this would mean is if you saw f of 2, if it something like this, f times 2 question mark? No, that is saying what is f of 2? And how would you determine what f of 2 is? You would look at your expression 2x plus 3, and you're going to substitute 2, not 3, in because the input is 2. So you're going to put a 2 in place of the x. And then you're going to do 2 times 2, which is 4, and get 7. All right, so we take the input, we put it into the function, and we get an output. And so here with this simpler example, we are going to take our input of 30, and we're going to input it, and we're going to get an output. So let's do that. So I'm going to write down here, I'm going to write my function over. And this one, x equals 30. So that means that I'm going to substitute in 30. And then do my order of operations. 0.5 times 30 is 15. And that's 14 minus 15, which is -1. So, shall we try -1? Hey, look at this. I can just. Ta-da! We got it. All right. Next question. And so, I think that this one's pretty. It's going to be pretty simple for you. All right. Evaluate functions. But if you want to see the algebra way, like Mr. Fields, show me more of that function notation from algebra, well, then you can just go to algebra evaluating functions, and let's see, it should look. See, there it is. So then there's that f of t, and then but it's the same thing. You're just substituting 7 in for t. Okay, so go to algebra 1 functions if you want to see the algebra way. But we're going to move on to evaluate functions from their graph. So we have a function that has, hey, and do you guys remember the acronym GET? So we just, well, that stands for graph, equation, and table. So we just looked at the equations of functions. So now we're going to look at their graphs. And yes, they have tables too. All right, but we're not going to look at the tables in this assignment. We're going to look at the graphs. So find the output y when the input x is -1. Okay, we will do that. So the input x is -1 where? Well, this is the x-axis. -1 is there. And so what is the y value of the function at -1? We go up to the function and we notice that it is at 3. So the function, this function has a point on it of -1, 3. And that means when the input is -1, the output is 3. I really like this annotation to it. Right here. Okay. So give that one a try, and there's also a related Algebra 1 assignment that is also called functions from their graphs that you can try in the Algebra 1 section if you like. It's noisy. All right, function rules from equations. Okay, so in order to write something as a function, the whole expression needs to be on one side, on the right side, okay? And then and then one variable by itself on the left side, like slope-intercept form, okay? So you can think about functions need to be written in slope-intercept. We're going to break that rule later on, but for now, that's a good rule of thumb for beginning functions, okay? So we see that here they want B to be the dependent variable. I forgot. All right, go back to your list with the input and the output and the x and the y and the domain and range, and add one more thing. Input. Wait, I mean input. I mean independent variable. Independent variable and dependent variable. The dependent variable is usually y, and the independent variable is x. And we can even write like y equals mx plus b. In this case, the y is our dependent variable, and the x is our independent variable. Okay, so lots of names for these two categories. You can tell they're important, can't you? All right, so here, what we want to do is we want a to be the independent variable. We're going to rearrange this equation here so that a is the independent variable, which means that a is on the right side. So let's do this. Let's move some terms. Okay, so let me let me rewrite it over here. 3a minus 7 equals negative 4b plus 1. Okay. And then we are going to get only b on the left. So then negative 4b is going to be on the left. And then it looks like everything else does not have a b. So negative 3a plus 7 plus 1. There I put all the other terms. I switched sides when I went over, switch sides over the line, change the sign. And now I'm going to look to see, do I have any like terms? And I do. That would make 8. So negative 4b equals negative 3a plus 8. Last step, what is it? Divide everything by negative 4. And when I divide everything by negative 4, I divide all 3 terms by negative 4. And so now we get b equals, and notice these negative signs cancel, 3/4 b, and these make a negative 2. So b is 3/4 b, and I'm going to put that b to the side. I usually put the variable to the side or in the numerator, but not usually in the denominator. Let's put it in the numerator. And I do the same thing for negative signs. They go in the numerator. You can put them in the denominator, but let's just put them in the numerator. You know, same spot. All right. Uh-oh. Uh-oh. Now, you know what I did? I put 3b, but I meant to put 3a. Man. All right. Now it says triangle. Let's just click it up. Let's see what I did wrong. 2 minus 3/4 a. What did I put? Uh-oh. Uh-oh. I messed up a negative somewhere. All right. Let me pause and find my negative mess up. I found my negative mess up. I made it negative. So that is a negative 4b. And when I put it on the left side, I did not change the sign. That just messed up everything. So it's negative 3/4 a, and then it's gonna be minus 2 or whatever. I messed up the sign. 2. Let's just wait. Plus 2. Okay, so negative 3/4 a plus 2. All right, let's do another one. You probably lost all hope in me here, but we're going to do another one. Okay, so x is the independent variable. That means that it's going to go on the right side. All right, y on the left side. So let's do this. Y is already on the left side. X is going over to the left side and it will become positive. Negative 8 is already on the left side, on the right side. Okay. Now we're dividing by negative 4 to get y by itself. And y equals negative 5/4 x plus 2. All right, if I messed up a sign here, then I'm just gonna re-record the whole thing. But I don't think that I messed up. That x to the side plus 2. Okay, that's better. All right, so hey, we all make mistakes, right? Put in the organizer if I confused you. So those are the 3 function assignments. And then after that, we're going to do a couple quizzes on linear functions, which is the slopes and the y-intercepts, linear equations that you already know. But at this point in the course, what we want to do is we want to keep adding assessments. There's another one, spaced practice, and there's a unit test in there. So throughout the weeks, you'll see material from the past come back up, but it won't just come back up as let's just do this all over again. It'll come back up all mixed together, because that makes your brain work even harder, and that is what we're here to do. All right, I will see you in class. Post in the organizer.